But how does this happen? In the cell, AMPA receptors are constantly being recycled. New ones are undergoing exocytosis onto the perisynaptic sites, where they then migrate to postsynaptic areas. And receptors at the postsynaptic areas are migrating to the perisynaptic sites, where they undergo endocytosis and are brought back into the cell. Endosomes inside the neuron are thought to contain a pool of AMPA receptors. A calcium influx large enough to cross a critical threshold will activate calcium-dependent kinases. These kinases alter the recycling of AMPA receptors. In particular, they increase the exocytosis of them. They also phosphorylate AMPA receptors, changing their structure to make them more permeable. This means that when glutamate crosses the synapse, more AMPA receptors are there to open, more current flows through, and the change in potential is increased. A more moderate calcium influx does not cross the critical threshold necessary to activate calcium-dependent kinases, and instead, it only activates protein phosphatases. These again alter the recycling of AMPA receptors, but in the opposite way. They increase the endocytosis of AMPA receptors, decreasing the number of them available at the postsynaptic terminal. This means that when glutamate again crosses the synapse, fewer receptors are there to open, less current flows through, and the change in potential